Hello friends, welcome to the another tutorial of Basic Electronics module. So our today's lecture is on the LED. So in today's lecture we will see or we'll learn the working of LED, different types of LED, advantages, disadvantages and application of this light emitting diodes. This lecture is divided in four different sections. In the first section or first part, we will see the introduction of light emitting diode. In the second part, we will see the working principle, that in what on which principle does the LED work. And in the third section, we will see the different types of LEDs. And in the fourth and last section, we will see the advantages, disadvantages, and different applications of LEDs. So, guys, let's start our today's session with the introduction to these LEDs. So, as we discussed earlier or in the previous lecture, that an LED is something which produces or generates light whenever there is a current flowing through its electrodes in forward bias condition only. So, when an electric current between the electrodes passes through this diode, light is produced. Or, in other words, light is generated when a sufficient amount of forwarding current passes through it. Now, in many diodes, this light generated is not visible because of the frequency level that do not allow visibility. So, in simple words, you can see because of the different frequency levels, so there are some frequency level which are not visible to human eyes. So many diodes generates light, but that light specific is not visible to human eye. LEDs are available in different colors. So as I have seen or I show you the different colors in the last session, there are so many different colors of LEDs available in market. So let's see what is LED. So, in a light emitting diode, the recombination of electrons and electron holes in a semiconductor produces light. So, what produce light in LED? The recombination of electrons and electron holes, be it infrared, visible, or UV. As in the previous slide, we just saw that in some cases or in some diodes, the light emitted is not visible because of the frequency level, which can be infrared or UV. A process called electroluminescence. So this process due to which the recombination of electron and electron holes occurs and light is produced, this phenomena called electroluminescence. The wavelength of light depends on the energy band gap of the semiconductors used. There are so many color of LEDs available. So now this color depends upon the semiconductor used and the energy gap of that. So the different types of wavelengths of light are available. In other words, a light emitting diode is a semiconductor device that emits light when an electric current flows through it. So whenever there is a flow of current in forward bias direction. Thus, these are the devices which emits light. When current passes through an LED, the electrons recombine with holes, emitting light in the process. Or as a result, LEDs allow the current to flow in forward direction and block the current in reverse direction. So LEDs are performing the basic function of diode, which is to allow current to flow in forward direction and to block it in reverse direction. So whenever a diode is connected in forward bias condition and electric current flows through it, it generates or emits or produces light. Light emitting diodes are heavily doped PN junctions. Based on the semiconductor material used and the amount of doping, an LED will emit colored light. So, these are some things or important things which have to keep in mind when we are discussing about LEDs. So LEDs perform this kind of task given the semiconductor, that which kind of semiconductor material you are using and the amount of doping in forward biased condition only. So the this diode or the color of light generated depends on the semiconductor material used and the amount of doping. According or depending on that, this diode will emit colored light at a particular spectral wavelength when forward biased. So as shown in figure, an LED is encapsulated with a transparent cover so that the emitted light can come out. So whenever there is a emission of light, it needs to come out from that particular encapsulated cover. So for that, the LEDs are encapsulated with a transparent cover, something like this. So this is nothing but a transparent cover, and this cover allows the generated or produced light to come out of this, and because of which you can see this as a blue color LED, this is as a red color LED, and this is as a green color LED. So the materials used in the formation of these LEDs are different, and the doping amount of doping is different. So this will give you different type of color. Now the second part of this lecture is working principle, that on which principle your LEDs work. So let's see the working principle. When the diode is forward biased, here please keep in mind when diode is forward biased. So this will apply only when the diode is in forward bias condition. The minority electrons are sent from P to N, while the minority holes are sent from N to P. Now at the junction boundary, the concentration of minority carriers increases. Now because of this recombination or this scenting process, the junction boundary becomes more or increases in the amount of minority charge carrier. Now the excess minority carriers at the junction recombine with the majority charge carriers. Now this minority charge carriers combines or recombines with the majority charge carriers. The energy is released in the form of photons on recombination. So this process of recombination is gives a result as a photons, or in return the photon energy is produced. In standard diodes, the energy is released in the form of heat. So in the diodes, the energy, or you can say the energy which is released in the form of heat, but in light emitting diode, this heat, there is no production, less production of heat, but high production of this photons. This phenomenon is called electroluminescence. Electroluminescence is an optical phenomenon and electrical phenomenon where a material emits light in response to an electric current passed through it. So whenever there is a flow of current, this kind of materials will emit light. As the forward voltage increases, the intensity of light increases and reaches a maximum. So with the increase of the forward voltage given to it, the intensity of light will increases gradually, and at a certain point it will reaches to its maximum intensity. So at some point or at some specific forward voltage, there will be a maximum glow or a maximum illumination of light will be there. So this is a pictorial representation of the working of LEDs. So this is how your LED looks like. This is your transparent cover. These are two electrodes. One is anode and the another one is cathode. This is anvil post, and this is semiconductor die. So this is a p-type region, this is n-type region. Whenever there is a current flows, or or say this diode is connected to supply or power source, provided the positive terminal of battery is connected to p-type and anode, and the negative terminal of battery is connected to cathode of that diode or N type of material. Only and only then there will be a recombination of electrons and holes. This recombination at the junction emits light or produces lights in result, which is nothing but electroluminescence, or this process is called electroluminescence. So this is something a deep thing which is there in the atom structure, and this is conduction band, this is valence band, and between these two bands this is called band gap. High band gap means there will be less amount of combination, or you can say less amount of the flow will be there, and in the lesser band gap or in the narrow band gap there will be a higher rate of the flowing of electrons from conduction bands to valence, from valence band to conduction band. So this is the constructional parts and constructional phenomena of LEDs. So where is DC volt given, the LED, the light will be emitted because of the recombination of these charge carriers. This is semiconductor chip, this is lens, this is cathode lid, which is always connected to the negative pole of battery. This is the anode lid, which is always going to be connected to the positive pole of battery. Now let's talk about the symbol, that how you can represent a LED in a circuit diagram or graphical way. So the LED symbol is standard symbol for diode with addition of two small arrows denoting the emission of light or the production of light. As you can see here, this is the simple diode, but in addition there are arrows which describes nothing but the emission, or you can say the production of light. And this is how your LED is denoted, or you can say symbolized. Since these materials have, so as shown in this figure, LED is encapsulated with a transparent cover so that the emitted light can come out. Since these materials have high index of refraction, design features of the device such as special optical coating and die shape are required to efficiently emit light. So these are the necessities to efficiently emit the light. These are the different colored LEDs. Now, what determines the color of LED? As I said earlier, that there are so many different types of LEDs available in market. So, what determines, or on which scale the LEDs are differentiated or determines as a red LED or green LED or blue LED? So the color of an LED is determined by the material used in the semiconducting material. So the basic of these diodes are the semiconductor materials. So the semiconductor material will decide the color of LED. The two primary materials used in LEDs are aluminum gallium indium phosphide alloys and indium gallium nitride alloys. So these are the basic two or primary materials which are used in the formation of LED. Now aluminum alloys, when there are aluminum alloys, or the aluminum material is used, then the red, orange or yellow light will be emitted. So whenever you want to obtain red, orange or yellow light, you will have to go with these aluminum alloys. And indium alloys are used to get green, blue and white light. So whenever there is a necessity of green light, blue light or white light, you will have to go with indium alloys. Slight change in the composition of these alloys change the color of emitted light. Means you can also use the combination of material to get the different colors of LED. So LED is nothing but a specific material, or the specific materials, and the combination or recombination of the holes and electrons and charge carriers, and because of this recombination there will be a production or emission of light, and that's why they are called as light emitting diode. Now here is the third part of our lecture, which is types of LED. So let's see the different types of LED available. So these are the types of LEDs, which are miniature LEDs, high power LEDs, flash LEDs, bi and tricolor LEDs, RGB, which is red, green and blue LEDs, alphanumeric LEDs and lightning LEDs. So first one is the miniature LEDs. As you can see in the image or in this picture, these are so small in this size, or you can say they are so small that uh, you can see them, or you can notice them in our TV remotes or some calculators, or these devices in which there is a small light available. So these are nothing but the miniature LEDs. These are mostly used now these days. These are available in single shape and color and available in smaller size. It can be directly placed into a circuit board without the use of heating or cooling device. So these kind of LEDs are so small, and the operating range and voltage are low. That's why they doesn't need a particular cooling device or a heating device. So they can be placed onto the circuit board directly. These are classified into low current, standard and ultra high output depending upon various factors such as voltage, total volts, current and manufacturer type. So these are the different classification of them, and depending upon the resources covered together, the different miniature LEDs are designed. Miniature LEDs are used in small appliances such as remote controls, calculators, and cell phones. So these are the areas where you can see this kind of miniature LEDs. Now, second one is the high power LED. This uses of LEDs result in high output compared to normal LEDs. So the normal compared to the normal LEDs, they have higher output. Means the ones you can see in the DJ system, or you can say in the event lights, where there is a or you can say the focus lights, where the higher amount or the higher amount of output is required. So this kind of LEDs are used that place of time. The light emitted is measured in terms of lumens. These are again categorized based on luminance, intensity, wavelength, and voltage. These have a danger of overheating, hence a heat absorbing material is used to cool it down. Now it has a very high output, hence there is a danger of overheating, and to reduce or to compensate that overheating, we need to place, or we need to use a heat absorbing material, or you can say heat sink, to cool it down. High power LEDs are used in high powered lamps, automobile headlights, in various industrial and mechanical equipment. So these are the areas where you can use this kind of LEDs, such as in automobile headlights, in various industries, industrial and mechanical equipments, and powered lamps. Now third one is the flash LED. With a normal LED, it contains an integrated circuit which flashes the light at a particular frequency. It flashes light at a particular frequency, hence it named as flash LED. These are directly connected to a power supply without the help of series resistors. So this kind of LEDs doesn't require a series resistor. They just are directly connected to the power supply. So this kind of LEDs are used in signboards and vehicle headlights. Now the fourth one is bi or tricolor LEDs. Now bi means two kind of color would be emitted, and tri means there are chances which in which three colors would be emitted. So bicolor LED lights consist of two light emitting dyes in a single case. Means in a single case there would be two lightning emit dyes. The wiring is inversely parallel, which means one is in forward direction and another in backward, which makes one dye lit at a time. Means in this type of LEDs, depending on the current, there would be emission of a single color at a single time. The flow of current alternates between two dyes, which result in color variation. Means the direction of current alters, and this alternating of current results in color variation. Now in tricolor LEDs, there are two dyes available, but it is designed the way that these dyes can lit separately or together, producing a third color. Means in separate they can produce two single colors, and in addition they can be joined together and produce a third color of the combination of the two main single colors. So that's why it is named as tricolor LED. Now RGB LEDs. R, G and B. So in this RGB, this R stands for red color, this G stands for green color, and this B stands for blue color. So this is something your RGB LED looks like. This is a type of LED, but it has 1, 2, 3 and 4. It has 4 legs. So RGB LEDs are generally two types, has two different categories. One is common anode and the second one is common cathode. So this is common anode type. We already know that the in diode or in the diode there is a longer term and there is a shorter leg. The longer leg represents anode and the shorter leg represents cathode. Now here these three terminals, or you can say these three legs, are dedicated for R, G and B to produce the single color. One will produce red, the other one will produce green, and the third one will produce blue. While this is the common anode which would get connected to the battery's positive terminal, and these three together will go to negative section or the negative terminal of battery. So these are the LEDs which are capable of emitting red, green and blue light, and also they allow to combine these three primary colors and produce a new color. These are used in accent lights, light shows and status indicators. So these RGB LEDs are used in light shows, status indicators and accent lighting. So this is how your RGB LED looks like. Now the sixth category or type is alphanumeric LED. So alphanumeric means the LED, or it would be something like a display. There would be something like a display, and on that display there will be alpha. Alpha means A to Z and numeric means 0 to 9. Numbers and letters both. So these LEDs can represent both letters and numbers. So in this category also, it is also divided in three subcategories. This consists of segments which offers greater flexibility and lesser power consumption. So these LED consumes low power. In it has various types, so such as 14 and 16 segments. So and here you can see the different types. This is 7 segment alphanumeric LED, this is 14 segment, and this is 16 segment. The segment means this part. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6 and this is 7. Means it has different 7 segments. And depending upon the luminance or illuminated area, you can see the different digits. In 7 segments, you'll see only different digits. So for say if the segment 1, 2 and 3, If these segments, only these segments are on, then you will see 7 number. If all the 7 segments are on, then you can see 8. If only this is off, only this segment is off, you can see it as a 0. So depending upon the areas or segment illuminated, you will be able to see the different numbers. Now in 14 segment, see, in 14 and 16 segment, they cover full 26 characters of the Roman alphabets in uppercase and with numerals 0 and 9. Means they are able to produce numerics as well as the characters, means A, B, C, D up to Z, 26 characters and numbers from 0 to 9. Now the 7 segment covers all the numbers and limited set of letters. In some of the 7 segment you can see some letters, but it covers all the numbers from 0 to 9. But in matrix segment, these are the 14, 16 and 7 segment, but there is also a metric segment available which covers full alphabets, means in uppercase and lowercase, and all numbers and a full variety of symbols, means it will give you upper and lowercase alphabets also, numbers also, and different symbols also. So this was alphanumeric LEDs. Now the seventh number is lightning LEDs, means of bulbs. These LEDs use aluminum or ceramic body which provides heat dissipation. One example is the Edison light bulb, the bulb which were used in in day-to-day life many years ago. So this is that kind of bulb. So this is our fourth part, which is the last section of this particular lecture. In this section, we will be covering the advantages, disadvantages, and applications of LEDs. So now let's first see the advantages of LEDs. So below are the advantages of LED over incandescent light sources, means the traditional light bulbs. The advantages of LED over the traditional light bulbs are they consumes lower power, means they operates on lower power. The lifespan of this kind of LEDs are longer, means they have longer lifespan. Improved physical ruggedness, smaller in size, and faster switching, means operating speed is faster. Now we will see that the how efficiency is advantageous. LEDs emit more luminance per watt than the incandescent light bulb. So, compared to the traditional light bulbs, these LEDs lumens or emits more lumens per watt, and hence improved efficiency. So, the efficiency of LED lighting fixtures is not affected by shape and size. So, this is something which is totally independent of shape and size. So the efficiency does not depend upon the shape and size of LED, unlike the fluorescent light bulbs or tubes. Now second is color. You have so many color options in the LEDs. You can have many more color options for LEDs. So LEDs can emit light of an intended color without using any color filters. So in LEDs you can get any color without using a color filter as a traditional lighting methods. This is more efficient and can lower initial cost. So by not using the color filters, the initial cost of the LEDs decreases. A third is cool light. In contrast to most light sources, LEDs radiate very little heat in the form of IR that can cause damage to sensitive objects or fabrics. So these LEDs are, you can say, environmental friendly or economic because they radiates less IR. which are causing damage to sensitive objects and fabrics. So they produce a very little heat. Wasted energy is dispersed as heat through the base of LEDs. So this was one of the advantage. Now let's see the lifetime. LEDs can have a relatively long useful life. So LED's lifespan is greater than the traditional light bulbs. One report estimates 35,000 to 50,000 hours of useful life, though time to complete failure may be shorter or longer. So now let's discuss the disadvantages of LEDs. First one is temperature dependence. Now LED perform largely depends upon the performance. You can say the performance of LED largely depends on the ambient temperature of the operating environments. So the operating environment is directly affecting the LED's performance. Over driving an LED in high ambient temperatures may result in overheating the LED, leading to the device failure. Means if we are using the LEDs in high ambient temperatures for so many hours, it can result into the device failure. Use in winter. Since they do not give off much heat in comparison to incandescent lights, LED lights used for traffic controls can have snow obscuring them and leading to accidents. Means they do not give off much heat, and because of that the usage of LEDs in traffic control lights during a wintry or snowy season can lead to accidents because of their obscuring nature. Third one is voltage sensitivity. Now LEDs must be supplied with a specific voltage. They are very sensitive to voltage. Means it should be operated to a specific voltage only. LEDs must be supplied with a voltage above their threshold voltage and a current below their rating. Means while using LED or operating LED, you will have to or you must be supplied it with the voltages above than their threshold voltage and a current below their ratings. Current and lifetime can change greatly with a small change in applied voltage. So by changing applied voltage, the current and lifetime of the particular LED changes. They thus require a current regulated supply, and that is why the LEDs need a current regulated supply. Now, impact on wildlife. That how does this LED impacts on our wildlife? Now, LEDs are much more attractive to insects than to sodium vapor lights. So if we are comparing LEDs with sodium vapor lights, then they attract more insects. So much so that there has been speculative concern about the possibility of disruption of food web, and thus this impacts highly on the wildlife. So now we will discuss these some of the applications of light emitting diode, which are visual signals where light goes more or less directly from the source to human eye to convey a message or meaning. Then illumination where light is reflected from object to give visual response for these objects. Also in measuring and interacting with processes involving no human vision. TV backlights, display, automotive, or you can say in vehicle headlights, narrow band light sensors where LEDs operate in reverse biased mode and respond to incident light instead of emitting light. So these are the application area of LEDs. Thank you so much. This was all about LEDs. We will see you in the next lecture.